Hello everyone. Today I will show you some new features of the Veselin platform, and at the same time I will try to answer some of the typical questions we get, which goes something like, okay, there are so many IoT platforms around, they do data analytics, and it seems that you're doing more or less the same thing. So in order to show you the latest features, I will start from the Nortonworks website, in which they are actually saying how they do the data analytics based on the sensory data. So what you will find there, it's tutorial on the HVAC systems, in which they have provide you with the zip file of the measurement data that you can find there. And then what they do is they load it in their application. And you can see it in tabular form how this data looks like. That's here. So you see the target temperature, actual temperature, and then the building numbers and so on. And then what they will try to do is to analyze the actual temperature against the target temperature. So you will end up with query of that sort, which says if I am below or above target temperature with a particular range, like here 5 degrees, I will then say that the particular building is in cold state or hot, or it's in normal state. They also provide later on the assets, if you like, the buildings, and they can load that as well, and then simply do the joins by saying what is the country with the worst performances and that kind of stuff. Okay, so what I will do today, I will download this zip file and I will try to replay it, but a little bit different. I will show you that in a moment. Now, you have to stay with me because this is going to be a little bit, I don't say complicated demo, but it will include quite some components of the Veselin platform. So in order to explain that, I will show you the architecture of the Veselin platform and what I will try to do. I will try to load this CSV file, the HVAC file, and I will try to mimic real-time measurements. In order to do that, I will use the push infrastructure and calls that allow me to push the real-time data towards the broker. Then I will use that inference engine to the reasoning. At the same time, I will use the dashboard to actually check the cloud cache data. And then eventually I would like to do the proactive maintenance, and I will show that how that actually works completely end to end. Okay, so let me go back to the lab. So I'm going to get here now, and first I will load the settings file, the file that actually includes my credentials. You will see that here happening. After that, I will load the HVAC file that I downloaded from the internet, and this is exactly the same table as you can see it here, and I just show here the first 3 rows. And then I will use the freeboard that I have already configured up front to actually connect to the cloud cache. So on one hand, I will be pushing the data from the browser towards the cloud broker. At the same time, through the dashboard, I will be connecting to the cloud cache and hopefully see the same values as here with some delay, obviously, because it has to be like a round trip delay between the browser and the cloud cache, and then coming back into this dashboard here. Good. So let's see how that works. I will start pushing this every 5 seconds. And if I start a simulation, I will see that data eventually gets pushed every 5 seconds towards the broker. And then I also see here at dashboard that we are as well connecting the data and presenting from the cloud cache back into the same browser. So this data, it's roughly the same. It is the same with a delay equivalent to the round trip delay between the browser and the broker. Okay, now that we have this simulation running, so let me go then to the Veselin application. So what we see here is that we have stream range sensor that will check the actual parameters. In this case, it will be the actual temperature. That is exactly the same parameter here that I am pushing from here. Then I would like to test it against the target temperature, which is that. And then I have something, a range, which is 5 here. That it's really no magic happening. We can see it here. So if I go to the functional nodes, I actually see that thing here. So I am fetching the data from the either from the runtime, or it will be put here as the absolute value. The same is for the range, while the runtime data has to come from the runtime. More about that you can see in other videos, but here it's a quick review of that feature. For the assets, they will be loaded. I took the CSV file and took a freedom to actually load it into the MongoLab. Reason being that I would like to enrich this data a little bit with the country information, longitude, latitude, and some other things. But basically, this is pretty much the same information as it in a CSV file. And then I would, what I have done here, I created a small sensor which actually fetches that information from the MongoDB. So that's here, and I'm actually here having the connection towards the, let me put one here. So if I have a building number 1, so let me check here, I should actually fetch the very first record from the database. Finally, for this demo, I'm also using another small mock-up of the, let's say, the customer support system. So I have here the support people, which are actually split per country. So I see here that Michael is responsible for Finland, US, and Belgium. So if I say something like Belgium, I should get Michael back. And next to that, I should also get email. In this case, it will be me, because for this demo, I would like to receive my email myself. And symbol, if I put here Finland, that would probably be the same guy. So let me put here USA, yeah, and stuff like that. More or less, you understand how this sensor works. Okay, now that we have that, so let's go back to this example. I will check whether they're in range or not, and here I will go against 5, like it is in that example. So basically this little node here is the same thing as this query. That's more or less what this sensor does. Here I will check and fetch the assets, the building number, and then I will see whether they're a incident, meaning that I have found a building and I have something which is below or above the range. And then here I'm showing you here a new features of the Veselin platform is that we can conditionally do the sensor computation based on the outcome of the other sensor. So in this particular case, I would say that as soon as I have an incident, I would like to know who is the person responsible for that country. Now you see here that I'm actually using as a country information which is found in the asset, because for a different assets that will be a different country, hence there'll be a different support guy working on that. Finally, if the issue is found and we have a guy who is in support, the person will receive something of this sort, an email with location of the problem, the building number, the current temperature, target temperature, and also will receive the outside temperature this time. Why? Because we will be then computing the outside temperature based on the city which is found for that particular asset. So in a way, it is very much the same thing as here, but that it has been enriched with some additional information as the outside temperature, and we'll try also at the same time to inform the workforce about a particular issue. So now that we have our system here in the lab pushing information every 5 seconds, and now that we have it here as well, that we check it in the cloud cache, we can start this test here. So let me close this as well, and this we don't need it anymore. So here we go. So what's happening now is that as soon as we start this task, the cloud broker will see there is one particular task which requires this information and will start the computation. So what you see here is that at one moment in time we are above the range, and then we'll find the person who is responsible at this moment in time to act upon that information, and that person will receive the email. So if I look here to the HVAC support, I see that twice I didn't have a person responsible because I deliberately have kept some of the countries not handled, and these issues will end up in a Zendesk ticket, because here I say that if there is no person found, then I will simply create a Zendesk ticket to inform that there are some countries which are not handled by the support. If I stop this, I should now receive quite a few emails, and let me go back here and let's see indeed what has happened. So let me read a few from there for you and say, okay, hey Light, we have issue in Hungary. That is the building. The current temperature is 55, target temperature is 69, so we are below. And by the way, the outside temperature is that. Obviously, see here that we have here Fahrenheit because this is the file that I kept, that I took from the website, and outside temperature here is in Celsius. Now, we also see for Spain, we have another person, Jose, please check. We are here above the target temperature, and by the way, this is the outside temperature. So this was more or less the demo that I wanted to show you for today. And I hope with this I can explain you the difference between, if you like, the analytics in IoT and the proactive maintenance. Thank you very much, until the next time.